This is Prof. Brady coming to you with a STATA tutorial on how to test for a unit root in your time series. To carry out this tutorial, I have a data set on the mortgage delinquency rate shown here in the data editor from 1991 all the way down to 2019. Notice in this file here, we have a string variable, which is the date. I have a numerical version of the date, the delinquency rate shown here, and then a trend variable. Now, if you check out the video creating trends and date variables in STATA, you'll see that it's very easy to create both of these things, and it's handy to have both in any time series DTA file. The trend variable comes in handy if you want to use it as an independent variable in a regression model or a forecasting model, and you can also use it to t-set your data. The date variable is handy specifically because if you t-set your data by this numerical date, then when you create graphs or test for breaks, the date is explicit. Keep in mind, you cannot use a string variable as the operational variable in t-setting. So you got to create a numerical version. Again, see the other video for how to do that. All right, to test for a unit root, the first thing we need to do with any time series is t-set the data, and we see it's the quarterly frequency. Then to check for a unit root, I always recommend looking at the series first, using the tsLine command, and you get a nice quick picture, and you can see the date on the horizontal axis. This is a really interesting series because you'll notice the giant spike right around the financial crisis of 2008, how long it was pretty high, and then the subsequent decline. In any event, it's difficult to know just from this picture whether the series has a unit root or not. We could certainly speculate. Check that, we can do two things at least. We could check the autocorrelation graph, which is another good thing to do. Here, the telltale sign that this series probably has a unit root is that this first autocorrelation is equal to 1. That is a bad sign in that respect. Now, to statistically test for it, rather than just use the old eyeball test, we use the Dickey-Fuller test on our variable. And the simplest version of the Dickey-Fuller test is just Dickey-Fuller with nothing after it. And that gives us the following output. And recall, the null hypothesis of the Dickey-Fuller test is that there is a unit root in the variable. So here, looking at the p-value, we fail to reject that null at the 0.05 level, indicating that this variable does have a unit root. You could also check alternative versions of the series or different versions of the Dickey-Fuller test. For example, you can test for unit root with drift using this modifier, comma, drift command, and you get a p-value of 0.3 in this case, still well above 0.05, so again, we fail to reject the null. So under the two versions of this test, we conclude, based on this series, that there is likely a unit root here. For alternative versions of the Dickey-Fuller test, you can go to Statistics, Time Series, Tests, and then jump into the module, and you can see alternative ways to model that unit root. It's not a bad idea to check different versions. If at least one of them, as a rule of thumb here, at least one of the versions of the Dickey-Fuller test suggests there is a unit root, just assume there is one, just as a precaution. And then to deal with the unit root, now that we have found that delinquency rate has one, all you have to do is create a first difference of the series or the percentage change. Here, the variable is already in percent, so I'm just going to do a simple first difference using the typical STATA time series commands. And just to check everything worked, look at your data file there, and you can see the new version of the variable. And then finally, double check the transformed variable is now rid of the unit root. And that appears to be the case from this Dickey-Fuller results, where the p-value is 0.0048, well below 0.05. So we reject the null and conclude that the first difference of the delinquency rate is now stationary and does not have a unit root. All right, stay tuned for just a second. At the end of this video, I provide a screenshot of a do file with all the commands that we executed here. Thank you.